In this video, I'd like to look at an example of combining multiple linear equations to develop a more complicated model. First, some general advice about constructing models. You might begin by choosing the variable. Try to identify the most basic element of the problem over which you have control, and make that your independent variable. Make that your input to the function you're trying to build. And also decide at this moment what the output of the function will be. What is it that you're trying to really describe in terms of this variable x? Translate the words of the problem into algebra. Express all the important quantities in the problem in terms of this variable x. And finally, take the quantities that you've now expressed in algebra and try to combine those in the appropriate way. And this will depend heavily on what the individual problem is. So we'll take a look at an example. A company currently produces orange soda that contains 5% juice. They have a 900-gallon vat of this soda, and they like to raise its juice content overall by adding pure orange juice. A natural model that we might make here is what will be the resulting juice content after we've added a certain amount of orange juice. Adding a small amount of orange juice to this large vat of soda is only going to raise it a little bit. Adding a large amount of orange juice could raise it a lot. So let's decide on our variables first off. We could make x the volume in gallons of pure orange juice that we're going to add to the soda. This is the thing over which we have control. We could add a small amount of orange juice, we could add a large amount of orange juice. So I think this is the most basic element over which we have physical control in this scenario. Once we've decided how much pure orange juice to add to the 900-gallon vat, we should be able to determine the new concentration of orange juice, which should be higher than the 5% that it began with. So can we translate the words of this problem into algebra? Well, the thing that we're trying to compute is the concentration of orange juice. And this is equal to the volume of orange juice that's in the mixture divided by the volume of the entire mixture itself. So how can we express these two quantities? The volume of the entire mixture we could write as 900 plus x gallons. 900 gallons that we began with, and then x gallons of pure orange juice that we're adding to this mixture. The volume of orange juice that's in the mixture is 45 plus x gallons. And where does this 45 come from? Recall at the beginning of the problem that the 900-gallon vat of soda that we have, 5% of that is already orange juice. So 5% of 900, or 0.05 times 900, is giving me the 45 gallons of orange juice that are currently in the mixture. And then I plan to add another x gallons. And then we can set up the model. We already said that the concentration should be the volume of orange juice in the mixture divided by the volume of the entire mixture, and we have algebraic expressions for both of these. And so I come up with a model of 45 plus x, that's the volume of orange juice in the mixture, divided by 900 plus x, that's the volume of the entire mixture. So how can we make use of this model? Suppose that we wanted to reach an overall concentration of 10% juice. Then how much should we add? Here's our model, that the resulting concentration after adding x gallons of pure orange juice is equal to this 45 plus x over 900 plus x. And what I know is that the concentration is supposed to be 10%. So that's the left-hand side of this equation. 10% or 0.1 should be equal to 45 plus x over 900 plus x. I could solve this using technology like Wolfram Alpha, and if for a complicated model I would recommend doing something like that. This particular example is not too hard to solve by hand, so we'll go over how you might do that. My first instinct is to cancel the denominator of the right-hand side, and that should result in a simpler equation overall. So I'll multiply both sides by 900 plus x. That cancels the 900 plus x on the right side, and then I have a factor of 900 plus x on the left-hand side. If I distribute the 0.1 across, now I have 90 plus 0.1x on the left-hand side. And now I just have two linear equations. Now I can gather all x terms on the right-hand side, gather all numerical terms on the left-hand side, and then divide to find that x should be 50 gallons. And so the interpretation in this scenario is that adding 50 gallons of pure orange juice to the 900-gallon vat that we started with would raise the overall juice concentration of the mixture to the 10% that we wanted.